All right. Hey, folks. Welcome to Study Hall. We've had a bit of an intermission while I've been kind of recovering last week from my second dose. I'm feeling better. I got my second dose of the vaccine. I'm feeling a lot better, and just really tired last week and just didn't have the energy to put on stream. But yeah, hopefully everybody's doing well and ready to get into some Python. So I have a little bit of a different plan for today. I'm going to be kind of improvising this a little bit, but I wanted to. We're fairly well through most of the Python material, or a lot of the Python material. We still have some Python material to go through in the Learn materials. But I just wanted to try this as an experiment, just see what people think about it. And I'm just going to pick some Codeword problems from Codeword here at random, and yeah, we'll just kind of go through this, and I'm gonna kind of highlight a few things as I work through these problems. The big reason I want to do this is I want to highlight workflow. Let's do this. So I want to highlight workflow techniques that I found to be useful in my own personal coding and working. So workflow are things that are not explicitly or only technical. They're sort of like, what does it actually look like? What am I actually doing when I'm solving a problem? Like what kind of little things can I do? You know, I'm obviously going to show you what I do. I'll speak for myself. So what like kind of little kind of things do I do to sort of optimize the process and help myself solve a problem quicker and easier? And I want to go over this because I know it can be. I know we have a fair amount of beginners in the pipeline at the moment around, and people I think can just generally, you can always learn better workflow. As I go, I always continually improve my workflow stuff as well. But I want to get people away from this idea, if you have this idea in your head, of like needing to fully conceive of a working solution before you start writing any code. You know, when you're thinking through a solution, there's definitely a fair amount of just thinking and just applying your mind to the problem. That doesn't necessarily go away, but what I want to sort of emphasize are techniques that can kind of offload some of the work of the sort of the more mundane thinking tasks into Python, so we don't have to, or you know, just into your environment in general, not even just Python, but yeah. So this is all going to be oriented around how do I use my tools available to me and the language and my terminal and the text editor to kind of do some of the tasks that I don't want to do. That's kind of the idea here. So it's all the stuff in coding that's not the actual code. That's sort of what I'm going to highlight here. And of course, we're just going to look at some problems to solve as well. Okay, cool. As usual, I'm going to do this if I don't see any questions. Right now, I'm not seeing any questions. So feel free to pop in a question if you have a question from Learn or from Codeword or whatever. Also, I know like we do push people towards doing Codeword and other just online coding platforms and things just to get a good amount of practice. So if you have any questions about what you see me doing, feel free to ask that as well. Cool. Let's without further ado, let's just jump into it. Okay, so this is Codeword. This is sort of the place where I like to start. I think if you just sign into Codeword, it'll take you to this like what is this, your dashboard or something? I'm not sure exactly what this page is, but what I always do when I'm coming to Codeword to do some problems, I'll come to kata here, click on that, and obviously you want to select your language, so you'll do Python. Make sure you're just getting Python problems. And then I just generally I'll kind of leave these settings alone, just select the language that I want to work out of. And then here you have your difficulty selection, right? So this part can be a little unintuitive. The 8s, so the problems are ranked in difficulty from 1 to 8, 1 being the hardest and 8 being the easiest, which I think is probably counterintuitive for a lot of people. So that's just something to remember. The range of the difficulty is pretty extreme. Some of the level 1 problems are like implementing like another programming language in Python or something, like a full or at least minimally spec'd programming language. I know there's one for like building a Markdown interpreter, which is Markdown's a very simple language to learn and to write, but building a Markdown interpreter, since it's a very simple language for us, it's involves a lot of logic for the computer. So a Markdown interpreter is a very non-trivial tool to build. So I've been told, just for reference, I've never personally done a level 1. I've been told that might take a Google senior developer an evening or 3 to do a level 1. They are very hard. So if you're trying to do level 1s and you're not able to successfully do them, don't worry. They're very large challenges. So if you're just starting off, you can select 7s or 8s. And you can also select a range by just kind of dragging your cursor. I'm not sure. The way the font is kind of coming up here is a little funky. It seems like there's a little bit of a glitch, but it should look a little different than this, so I don't know what's going on there. But if I just hold my mouse over this and then just drag my cursor, it'll select all the ones that all the difficulty range that I want to work in, right? So if I do, that's just 8. If I wanted to do like 6s through 3s, I could just drag through there. But let's just do 8, 7, and we'll just throw in some 6s in there, and this will just show us different problems, and we can just pick from here, right? So maybe we'll do a 6 today, but I'll just start with something easy, something real easy. We'll start out with a couple 8s and doing some 7s, and maybe we'll get into a 6 later on. Cool. Looks like we got a question here. Somebody's saying their premium prep doesn't start for 2 weeks, but figured you'd pop in and see what's going on. Well, welcome. This is Study Hall. Yeah, you probably heard me go through the whole spiel. I'll save you that. But yeah, this is just a medium for you to ask any Python-related questions you might have, especially regarding our material. But just Python questions in general. If there's a topic that you want me to explore, I'll be happy to go through it. So welcome. Cool. All right, so let's just pick a problem in here. Let's see. I opened this one. I forgot I did. Okay. So it'll kind of take you. I don't know why it's giving me everything in JavaScript. I think I selected JavaScript like 3 weeks ago or something, and now it thinks all I want to do is JavaScript. Anyways. Okay, so obviously you got to select your language, make sure it's on the right language, make sure it's on Python. Looks like I've already done this one, but we will just do it again. So up here it'll usually say train or train again if you've done it already. Cool. So just a quick rundown of what you're seeing here. On the left, you've got your problem statement. And this is actually 2 windows here. Excuse me. I'm getting my traditional hiccups during streaming. I never get hiccups except when I'm streaming or lecturing. I don't know if it's the talking. I don't know what's going on. Anyways, um, so this section is where you'll see your problem statement, and then when you run your code to test it, you'll see the output here. Now Codeword does this thing. Overall, I really like Codeword as a platform. There's this kind of funny thing though that they do where that I don't totally like, which is whenever if you hit attempt and it's not right the first time, they like deduct points from you. So what I recommend is don't do your work out of Code Wars. Don't actually do the work in the Code Wars REPL environment. Either go to Replit or use your local environment. And I'm just going to use my local environment that I'm comfortable working in, because I'm comfortable working in it. So yeah. So obviously we got to read our problem statement, and this little section down here is a section that's kind of easy to ignore. This is some sample tests, and they usually just have a few, sometimes only one. I like it when they have a few. There are other tests behind the scenes, like when you actually hit attempt here. Sorry, that's probably a little small. Let me increase the size of that text a little bit. That's probably a little better. Apologies about that. So attempt. Let me adjust this. So attempt in the bottom right corner there. When you hit that, it will run other tests, right? So it may be the case that you pass these initial tests, but you don't pass all of the other tests that they have. And I kind of find that annoying. I think it'd be really cool if they just gave you all the tests and they didn't like hold points over you, but that's their platform. It's a game, sort of overly gamified, but it's still pretty cool. I still really like Code Wars a lot, and it's still fun, and it's a great resource. So cool. Let's see. Let's jump into this. So what I usually do, I'll just copy my problem statement, and I only have one highlight here, but that is the highlight workflow. Okay. I'll put it into a multi-line string, into a comment, into my environment here. Okay, so another thing I'll do is I'll copy in the tests here, and this is using a testing library that we're not gonna get into here, but I'll kind of show you how to read the important parts of this. There's a lot in here that you can just basically ignore, and I'll show you how to write your own tests. Okay. I'm going to comment that out for now. Okay, cool. So, yeah, let's get back to that in a second. Okay, so for this problem, your goal is to return a multiplication table for number that is always for a number. This is the other thing about Code Wars. Some of it's not just Code Wars. This is the thing about engineers in general, sometimes myself included. We can write code, but not necessarily copy. Okay, so your goal is to return a multiplication table for a number that is always an integer from 1 to 10. Okay. For example, a multiplication table string for number equal to 5 looks like this. So this is just going to give us our fives column in our multiplication table. So 1 times 5 is 5, 2 times 5 is 10, 3 times 5 is 15, etc. So you can use a \n. This is a new line character in a string to jump to the next line. So it looks like it's telling us it wants this particular output, and we're going to kind of see that down here in our tests here. So it's kind of giving us a little test here. So note new lines, which is this \n here. New lines should be added between rows, but there should be no trailing new line at the end. Okay, so there should. Okay, that's why it had it like that, because there's no extra new line there. Okay, cool. So for those of you who don't know, I'll just cover this real quick. A new line character is a character in a string that pushes the characters after it to the next line. It's the character that's entered when you hit your enter or your return key. So the way that Python represents that character in Python strings is with a \, and an n. The \/ is the escape character. It kind of means that the character immediately following the \ is sort of treated differently than the character literal that it would usually represent, right? So instead of this being represented as the character \ followed by the character n, when it sees \n together like this, it knows, okay, so I'm going to treat that n as a new line rather than the n character, right? So I'll just make a string here. If I say my string, I'll make a variable, my string equals hello, and we'll do \n world, right? And if I go for my string, oh, it literally is just going to put it in. Okay. All right, IPython. Fine. Let me do it this way then. Print hello \n world. Okay, that's what I was trying to do. I don't know why it does it differently in the terminal there, or in the yeah. I wonder maybe I do need to print it out in the terminal. Yeah, I guess that it works if I do that. Okay, so you can see when I print this out in either case, it puts world on the next line. That's all that's happening here. Okay. So now let's get into these tests. And I commented these out because we were going to kind of ignore them. So first of all, let's talk about what a test is. I remember when I first was learning to code, and somebody was talking about testing and how cool testing was and how important it was, and I instantly became afraid of it. I was like, oh, okay, so not only do I have to know how to write code, I have to know how to write code that like analyzes other code. And that is what a test is. It's code that in some way analyzes or lets us analyze the code, the results of the code. But if you think about it, a test is actually a very, very simple idea. So it's an idea that if you're a beginner, I want you to be unafraid of testing right now, because it really is not a big deal at all. So overall, testing as a subject in programming is a big topic. There are lots of techniques it can get really advanced. There are testing libraries. There's multiple testing libraries. This is, if we look at this import, right, Codeword has their own testing library that this is using. And then there's test classes and object-oriented workflows, and then there's all kinds of ways to integrate tests into your project. But the kind of tests that we're going to do are going to be just really simple. All they're going to involve is print, and that's it. We're going to be writing functions, and we're going to be printing the results of those functions, and just seeing if that matches our expectation, right? So that's basically all a test is. A test, and let me kind of generalize that a little bit. So all you need for a test is obviously a function to test, which we're going to do. Let me actually write the name of this. Return good luck. All right. We'll come down here. Okay, so here's the function I'm going to test. So what I like to do is break this out into a couple variables. We'll kind of make a distinction here. So here's where I'm going to define the function, and then here's where I'm going to test it. So all we need to build up a test is we need to know for a given input into the function, what is the expected output? What's the output that we expect, right? So if I give this function, if we look up here, right, this is basically describing a test. If we give this function 5 as an input, if the number equals 5, we should get this output, right? I will note the type of the output, which it says here is a string. So I know that it basically wants this out as a separate string. So let's do that. So I'll say for this input, which I'll call imp, equals 5, our expectation, and I'll call our expectation exp, is going to be a string, and I'm just going to do, I'm going to do a multi-line string like this. This might look a little funky. It's formatted a little strangely. I could do something like this, and often I'll do that, but I don't want to do that here because of new lines. I don't want to add in new lines. So when you have a multi-line string, it allows you basically just to add in new lines without having to type \n, which is a little clunky. So I'm going to leave it, even though it looks like it's formatted a little strangely. If I put a new line here, that would be adding a new line character on the end, and remember, it actually explicitly said not to do that, so I'll just leave it alone. So for this input, we expect this output, and then let's capture the result. So I'll call this res for result, is going to be this with input, and then in the print here, I'm just going to do I'm going to do res equals exp. So this is a check for equality. This is a Boolean expression. It'll express true or false. It'll express true if res is equal to exp. So res is what we actually got, a result, and exp is what we expected to get. So does our result match our expectation? So this will be nice. It'll tell me true or false as to whether this test is passing or not. Right now, if I run this, it's not passing because we haven't done anything yet. So that's fine. So that's going to tell me if my test is passing. And then what I always like to do is print the result as well. This is currently returning none because I haven't asked it to return anything. But we'll get there in a second. Cool. Let's see. Yeah, so this is sort of the basic structure of the tests that I like to do. And if you want something easy to remember, I mean, you could structure this a lot of different ways. And a lot of times I'll sort of just like, instead of doing an expectation like this, sometimes I'll just like write the result here just in a comment if it's like a number or something, if it's small. So I don't even usually go, or even I don't often go this all out, but hopefully this doesn't seem too intimidating. All we've got here is just a few variables, and we're just printing them out. So this is not a formal test in terms of like full-on TDD, which is test-driven development, but it's gonna do for our purposes. And when you're just problem solving on your own, this kind of thing is often all you need. Yeah. So even though it's simple, it's still very powerful. Whenever I go about solving a new problem, if I anticipate that it's going to be challenging, this is the first thing I do. So I'm actually setting this up like I normally would. So now that we have our test written, I was going to say, if you want something easy to remember, input, expectation, result, imp, exp, res. Just have those three things. So you want to know what your for a given input, you expect a given output, and then you want to know what you're actually getting. So those are the only three things. Print them out however you want them. This is just the way I'm doing it. Okay, cool. So we have that one test. Let's look through here, and remember, this is what I copied from Codeword. Oops. This is what I copied from here. So let's kind of pare this down into something that's useful. So first of all, basically what I'm going to do is I'm going to look for any line that doesn't contain a call to my function. So the function that I'm testing is molt table. I see that called twice here. So what I'm going to do, just section those off, and I'm just going to delete everything else. We don't care about everything else for now. Anything else for now. Then this test assert equals. Basically, we can just get rid of this as well. And what this is saying is basically what I'm doing up here, right? So test assert equals is just saying it takes, this is a function that takes in two inputs, and it returns a passing test if the two if the two arguments given are equal to each other. So if we look here, molt table 5, right? So this is taking in the input of 5, and this is actually the input that we're testing for up here. So if we looked through this, we'd see that it was the same, except for instead of new lines being printed off like this, they're printed off with an actual, or they're written with an actual \n. Okay, so we actually don't need this one because this is the one we just wrote. Multiplication table of 1 is going to give us something different. So if I look at this, this is structured differently, but it has all the same elements, right? This is our result, this is our input, just this one right here, and this is our expectation. So I'm going to do the same thing. I'm going to say, oops, imp equals 1. You don't have to call it, I mean, you could put the input in here if you wanted, but I'm just doing this because this is the way I do it. Exp and our res equals this, and then I'm just going to print res equals exp res. Cool. Now the cool thing is, if I wanted to make another test for some reason, I could just duplicate that. And I do have to think through this, right? So let's say I wanted to do the input of 3. So I just have to change all of these. This will be 3. Oops, I missed one. 3 there. Okay, so and then I have to change the answers, obviously. So 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is, oops, is oh, come on, is 9. 4 times 3 is 12. 15. 18. 21. 24. 27. Yeah. And then 30. Okay. So that's all I have to do to make a new test. Just change the expectation and the input. And that's why I kind of like to do variables like this, because I can just keep the rest of the test basically the same. Okay, so we've got 3 tests here, which is great. It's more than we usually need. You don't necessarily need to write a bunch of tests. Write at least one. Sometimes your expectation, you can kind of fudge it a little bit. If it's simple enough that you can tell by eye, you don't have to get it exactly right, but you want to get it as close as you can before you start the problem. So, okay, now, so I want to do a little bit of a reflection right now, right? So obviously I'm going slower since I'm kind of explaining my process and talking about what I'm doing. But it's important to have a good setup. It's important to set yourself up in a way that's going to make problem solving actually easier. Oh, wow. I'm not sure what's going on with the camera there. Is it really that dark in here? Sorry, it looks like I have some filter on, but I think the light level just got a little too low. Let me just go turn on my my light here real quick. Apologies. Okay, sorry about that. Yeah, so I was just saying it's important to, do a little setup first. That way you don't have to do it in the middle. You don't have to get into the middle of a problem and then realize there's something that you want to test and then kind of stop doing what you're doing and then go write the test and then come back and you kind of forgot where you were because you spent all that time doing busy work that you could have done before you started the actual problem, right? So this can save you a lot of work in the end if you just do it up front. And I'll tell you from my experience that we always, myself included, want to get straight into the meat of the problem and actually building out the logic of the problem and solving the interesting problem, because kind of that's where the fun is. But it really is worth it to write at least one test before you jump into things. So cool. And it does become fun. I actually do find test writing fun, to be honest, because you're kind of thinking through the problem in a preliminary way, right? And you're writing a validation for what the problem should do, which is kind of fun. Okay, cool. So let's jump into this. All that to say, it's important, write at least one test, and just remember your input, your expectation, and your result. So let's jump in and see what we're actually supposed to do. So we're returning a multiplication table. Okay, cool. So I'm thinking we've got number here. So we've got to return a string. This is another thing I like to do. I'll call this table. I like to put in my return right away before I jump into the rest of it, and it just gives me an idea of, obviously, of what I'm returning. And if I want to print it off, if I want to see, the changes made to my return variable at any point, I just run my code, and I can see the current state of that variable. Currently what I'm getting. Am I even if it's not totally finished yet, I can say like, oh, is what I just did getting me closer, or is it getting me further away, right? So whatever the return type is, I just make a variable of that type and just return it right away. This one's going to be an accumulator, I can tell, because we're going to be multiplying our number times every number in a range from 1 to 10. So let's just knock out all the things that are obvious as much as we can. So we've got our return, which is our multiplication table, and we want to multiply number by every number in that range. So we'll say for I in range, this will be 1 to 10 plus 1, which we know is, in fact, through science, we know 10 plus 1 is 11. Thank you, science. So just for clarity, I assume that most people watching this will know, but just for clarity, because I think we got some beginners on the stream today, the reason I'm building out this range to go from 1 to 11 and not 1 to 10 is that the upper bound in the range is not included, right? So this is actually going to go from 1 to 11, and it's going to stop short of 11. So I want it to include 10, so that's why I'm going to 11. And that's just the sort of the baked-in behavior of the range function. Excuse me. Okay, so from here, I'm going to kind of just do a little test. I'm just going to print number times I. And this might seem really obvious, like why would I do this? But this is sort of the point, right? Is this operation going to give me this part of the string that I need to build up, right? And if we look, I got a bunch of output. I got a whole bunch of output here, so I'm seeing way too many tests here. So I'm going to pare this down, and I usually do this. I usually just work on one test at a time, so I'm going to just comment out those prints for now, and I'm just going to focus on one test at a time. So obviously I should just see numbers counting in 5s. Let's see. That is, wait a second. Is this? I feel like something's gone strange here. I am literally not seeing what I'm expecting to be seeing here. Oh, yeah, okay. Yeah, it's funny. I commented these out in a different way than I normally do, and I forgot what I was doing. Okay. That's on me. This is usually what I do. Oops. Oh, that's going to conflict. That's okay. Comment them out like this. Okay. Sorry about that. Let's run that again. Okay, so since I'm printing in the function here, I'll just label this, we'll call this product. Something like that. Okay, so this says product. You know, I'm just printing off this string plus the result of number times I is going to be 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And then notice we get false. And I'm surprised we're not actually seeing, oh yeah, we're not seeing anything after the false because we're returning an empty string, so it's actually printing an empty string, even though no characters are printed for an empty string because there's nothing in it. So if I look at this, this gives me sort of the right-hand side of this string that I'm trying to produce, right? So I know that that's part of my solution sorted, right? So I want to start constructing this string, this table string. So I think I'll do, I just want to think about this as every row for now. So every row is going to be table plus equals, and I'm going to do an f string of, oops. I know that the ending part is going to be number times I, and that's going to be like this. I'm working from right to left. I don't know why, but you know. Let's do this. So it'll be I space star number. I think that'll be it, and then we'll need a backslash n on all of them except the last one. Okay, cool. So we're really close. If we look, this is really close. The one character different. So notice that went from false to true. Like if I change the expectation, right? So it's false. It looks right? But if I add in that one last new line character, which to be clear, the test says, or the problem states explicitly to not do that, which I'm currently doing, but that's okay. If I add it in there, it does match, right? So that tells me that the only thing now that I have to worry about is this final new line character. That's the only problem that I have, which is a good problem to have because it's only one problem and it's pretty small. Cool. So I'm pretty close. If you're new and you're looking at this line, it looks like a lot. I don't want to throw too much at you at once. This is an F string. We have some of our material that'll cover it. If you look up Python F strings, you can get a good explanation of what that is. Basically, F string stands for format string, and basically what it allows me to do is sort of template into the string different variables and things, right? So I get the value of I gets evaluated as a variable and then turned into a string and placed into the string inside the curly brackets, etc., right? So that's basically what's happening there. Cool. Okay, so I fixed my expectation. Now I think that there's a method that I can use that will turn this into what I want. But you know what? I just thought there's sort of another way I can do this. I could do this with a list, and I could dot append like this. I could append this element as its own individual string, and I'll take off the new line. And then when I return it, I can string new line dot join. So what this is going to do is it's going to take this list of strings and join it into a string with the new line as a separator, so it's going to put it in between, and this prevents it from being put on the end. So if I do this, look at that, true, which means we have a passing test. Congratulations, everybody. You watched me solve a problem. Okay. Cool. And yeah, let's just submit this. I'm just going to hit attempt right away. You can do test and it'll just run the test. It did succeed here. Now, just for fun, I'm going to rewrite this as a comprehension. You don't need to write all your code in comprehensions, but it's fun. If you know comprehensions, they're fun. Okay, so I'll do this for this. And then we'll join return \n.join like that. Okay. There we go. That was kind of a lot. But just for reference, this is a comprehension. It sort of involves all the same elements that I used, but it's just a way of sort of wrapping it up into one line, right? Which is, this is the part right here on line 33 that I've highlighted. That's the comprehension. And then this \n join is exactly the same as what I had. So this generates that list that I was calling table and appending to. This is what I was appending, and this is the for loop head that I was running through to do the append. And this is just how a comprehension is structured in that alternate order, but this should work as well. Some potential benefits of comprehensions is that they're potentially, I've heard them like touted as being like much more efficient. I don't think that's really true. I should probably like benchmark that and like do my own tests and like investigate that. I have seen them have like some small performance gains in certain circumstances. There may be other circumstances where those performance gains are significant. But yeah, anyways. So I just submitted that. And then now we get to see everybody else's submissions after we solve the problem. And you can see it's pretty typical that people took the solution that I did as well. I think this is exactly the same. \n.join on an f string, same f string range. So here's something similar. They used a .format string. But yeah, you can kind of peruse through here. Somebody who took a more procedural approach. You can kind of peruse through here, and I always like to just like look through and see if there's any ideas that I didn't think of. You might look at this. Like here's a different kind of solution. This person's writing a lambda function, which is sort of an alternate way to write certain kinds of functions, which is kind of cool. Right, so you might learn something looking through and seeing other people's solutions. In fact, you definitely will, Cool. All right. Let's see here. Chomp. Okay. Cool. Just a quick reminder, if you've got any questions, feel free to drop them in. I'm not seeing anything at the moment, which is also all right. So I'm going to continue on. We'll just pick another Codeword problem. And I'll go a little faster through this one. I just wanted to give a nice, thorough kind of explanation of this first one, just so we had a sort of something to, a touchstone to go back to. Let's just do another. Let's do maybe a 7, or I don't know. Shorter concat, reverse longer. Oh, that's a really descriptive. I have no idea what this problem's going to be. Okay, let's just train. Chomp removes new lines? No way. Hello? Chomp? Alright, you got me. Oh, in some languages, not sure about Python. Okay, sorry. I was like, oh, you're messing with me. That's fair. You're welcome to mess with me if you want. I'm open to that. There is a function. There is a method called strip that I think will remove. I know it removes white spaces from the ends. Oh, it takes an argument, so I could give it. Yeah. Now I'm curious. Now I'm curious if strip would work. Oh, now I'm so curious. That's initially what I was going to do. Let's actually just do that, just for fun. I mean, I find it fun. Okay, this is where I was going to do it. So I was going to do, let's just do a quick test here, make sure we're getting a fail. Okay, so this is failing again, and if I do the new line, is that going to make it pass? Yeah, okay, so that's all we need. So if I do dot strip, so dot strip will remove white space at the beginning and end of a string. A new line is a white space character. Yeah, so that'll work as well. So we could just do dot strip there. So that's probably the analogy, like in Python to chomp. Yeah. I like chomp though. That's fun. I don't know. I don't know any languages that use chomp, but I suppose I'll just have to keep learning languages until I find one that uses chomp, so I'll be satisfied. Cool. Oh, it's from Perl and PHP. Oh, okay. Makes me think of Pac-Man too. That's what I was thinking of. Cool. All right. Okay, we're good. On to the next one. All right, so problem statement, real quick. Always like to have this on site. I'm kind of a believer in this. Just take the problem statement, just put it in your editor, because you can edit it around and like mess with it and change it and like format it in a way that's clear to you, because I guess engineers can't write copy, and sometimes you need to like just go through and like, okay, I think this is what they meant, and I think this is okay. Anyways, not all, a lot of engineers can write copy. Okay, we'll come back to that. I'm just going to grab these tests really quick. These look like nice and simple tests. And we'll just turn those into prints like that. We've got line ending characters, because why not? So I'm not even reading the problem statement. I'm just doing setup stuff right now. I don't even know what this problem is about. Return. Okay. So it looks like this is our, oops, oh, these are our expectations. This is our results. Oops, not assigns, that's equals. And we'll do res equals this. And looks like these are our inputs. I'll just leave those there for now. Like that. Let's do this. Okay, so the result of this function with these inputs is stored in result, and then for these inputs we expect this output, I guess. And then we're just going to print that off. Oops, and I meant to do, whoops, res equals exp and res. There we go. Okay. We're going to get an error because I didn't specify any parameters, but I'll do that in a second here. Okay, so also errors are good things. The more you get, the better programmer you're going to be. The quicker you're going to improve as a programmer. Okay, so given two strings, A and B, well, that's easy. A, B. Return a string of the former, or no, wait, excuse me, I'm dyslexic, unironically. That's form. Okay, return a string of the form short plus the reverse of the longer plus the shorter. Okay, so short plus reversed longer plus shorter. So this is going to be easy. So let's just determine whether A or B is shorter. That's kind of our first step. So in other words, the shortest string has to be put as a prefix and as suffix of the reverse of the longer string. Okay. So if I had a variable called shorter, that was a string that was the shorter string, and I concatenated it to the longer string, and I'll reverse it, and concatenate it to the shorter string. So I'm kind of solving this problem backwards, which is highly recommended by me. Just imagine you know, like if you had these variables, this is how you'd use them. So now the only trick is to get the shorter of the two strings into the variable called shorter, and the longer of the two strings into the variable called longer. Pretty easy. Okay. So determine whether A or B is shorter. So from here, we can just do some control flow. If len A less than len B, shorter equals A. Oh. Nope. Hitting all the keys. LONG. Longer equals B. And else shorter equals B, longer equals A. Oops. But what if they're equal in length? So I should probably read the rest of the problem statement. Okay. So in other words, the shortest string, prefix, suffix, blah blah blah. We read that. Strings A and B may be empty, but not null. In C# string, we don't care about C#. If A and B have the same length, treat A as the longer string. Okay, so oh, that's good. That's what I did. Okay, so if A and B have the same length, treat A as the longer string producing B plus reverse A plus B. Okay, good. So that's actually what I did. And that was kind of my assumption that if one of them, if they were the same length, that we would just assume that one of them would be the longer one. I just happened to randomly choose the correct one. So, yeah. And I'm looking at this and I'm thinking, how can I kind of just make this a little more elegant? It doesn't really matter. I mean, this is going to work. So look, true, true, true. These all pass. I imagine, let's just make sure. I don't know why this wouldn't pass. We'll just attempt. Looks like it passed. But I kind of want to clean it up just a little bit, just for fun. So I could turn this into a ternary. I could do shorter, longer. Oops. Shorter, comma, longer equals A, comma, B if len A is greater or is less than len B, else B, comma, A. Oops. We'll just comment that out for now. Too many values to unpack. Interesting. I wonder if I can't use a ternary in that way. Or maybe I have to be explicit about these being tuples. Not sure. Ah, I do. I just have to put those in parentheses so that they're explicitly tuples. That's nice. It's kind of easy. Okay. So those do pass the test. Let me see if there's 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so these two inputs have an equal length. So this is being tested for. Of course, that's something that I probably should have mentioned. You know, if you're copying your tests from Codeword, you should probably just give them a quick look and, you know, make sure you understand what they're testing for. You know, it's probably a good idea. But if you don't, you can always check later. And that's kind of the benefit of writing your own tests too, is you can make sure all those cases, all those special cases are accounted for in your own tests. Cool. Looks good. So we could do this one, and I'm sure this one would work. I don't see why it wouldn't. That one does pass as well. I do think just for fun, we could even do yeah. We don't even need this. We could just return A. Let's just do this. Let's do it right in line here. So we'll say A plus B reverse. I'm using a slice to reverse here. Plus A. And I'll just do this. I'll just swap A and B over here. Let's try that. So we got 3 truths, so that looks to be passing, and oh. And these other, honing it down onto one line, I don't know. It's for me. It's just for fun. It's just like it's cool. Um, yeah, if it makes sense to you, like the long way, like this. This is actually the same code, really. Um, it's I would consider it like logically identical. There might be a performance optimization in the one liner, or there might not be. In certain cases, there can even be a performance impact. You will see this on Code Wars, where like there's an emphasis on trying to get everything into one line, and as a challenge, I find it amusing. I find it fun. Uh, when you're learning to program, don't if you can't write your code into one line like this, that's fine. Don't worry about that at all. Anybody that tells you that you have to do that before you can consider yourself a programmer is a liar, and you shouldn't listen to them. In my opinion, and I'm correct also. Um, but yeah, this writing code like this is fun. I think it's like it's a little extra challenge. It's like, well, why not? But you can build yourself up to that. This solves the problem, and there should be no shame in a working solution. If you write working code, like you're doing it, so it's all good. Um, yeah, yeah. Sometimes they can be slower or faster. I think people like there tends to be a conflation with performance gains and like less code. In an interpreted language, that's not necessarily the worst assumption, because it's interpreting every line of code in your it's interpreting everything in your logic. But for example, something like a longer variable name is not a performance impact. So like more characters doesn't necessarily mean anything one way or the other. But I think so. I am using a ternary here, which returns a value, and I think ternaries, since they're a little more limited in what they in like all the various things they can do than if else's. I think that they're slightly more optimized, or that they can be. There's like this whole thing about there's a whole philosophy of programming called branchless programming, where you try not to use if and else at all. And academically, I find it really interesting. In terms of like practical software writing, I'm like, oh, that seems kind of terrifying. As a challenge, it's neat, but as like a practice, I think I'm kind of like, I don't know about it. But yeah, and for whatever like modicum of performance gain that we might gain from this particular thing. But yeah, so I think people conflate it, because comprehensions um, are known to be faster than like for loops and things, but they're also more limited. So anyways, it's just for fun. Also, like if you're new to coding, one thing that almost everybody, myself included, when I first learned, almost everybody what's the overvalues the importance of optimization. Um, a lot of times, optimization isn't in reality. Optimization isn't important. Um, a lot of like if I know that I'm going to apply something to a problem, and I'm going to write an algorithm that might be unoptimal, but the problem that I'm applying it to, maybe I'm gonna, I know that this is this code is only ever going to operate on a data set of a couple hundred items, and that the optimization gains won't be realized until, like this kind of algorithm is dealing with maybe tens of thousands of items. So the amount of work, might be really easy to just like throw something quick and easy together that's easy to maintain and easy to deal with and easy to just wing off real quick. And that's fine. In a lot of circumstances, that's fine. Also, often the way around, especially in languages like Python, the way around like performance barriers is bigger computers, often. And it's not that I don't want to make it sound like I think optimization is bad or that you shouldn't do it. I actually really like it. I find it like optimizing problems to be really fun. I don't want to point people in that direction like, oh, you have to make it the most, algorithmically enlightened mega solution. Just like, nah, if it works, that's cool. Anyways, okay, I talk a lot about that, and I'll shut up. Cool. Yeah. Good rule. Oh, somebody's saying, okay, good rule of thumb is to make it easy to read for junior programmers until you have a performance problem. I've never heard of that or thought of it that way, but yeah, boy, does that really just sum it up. Um, that's exactly my sentiment, although more elegantly expressed than I've been able to put it thus far. Yeah, make it readable to like somebody who's not like uh, ultimate master coder until you need it to be performant, and then like if you make it unreadable, then that's just what you need to do. you know but emphasizing readability in your code, I think it's funny, like when you start coding, you're like, oh, I've got to make super optimized solutions, and like code is a way of communicating to the computer, right? That's not really true. It's kind of funny, but like code is for us, a programming language. Like the computer doesn't care about Python, right? It doesn't care about C or C++. The language is for us. The language is a tool for human communication, not computer communication. Often it's in a high level, very algorithmically focused language like Python. Um, Often the person you're communicating, the audience for your code is not only the computer, but it's other developers, and often it's yourself, which is kind of a weird twist. But like, you write some code and you come back a week, even a couple days or a week or a month later, and if you wrote it in a really weird way, it's totally possible that you look at it and you're like, I know I wrote this. It's on my computer. It's in my GitHub, but like I don't recognize this at all. So it's useful to develop, like over time. You start to realize, like when you start, you're like, I got to write optimized solutions, and I got to write the best code I can for the computer. And then after like you get some experience under your belt, you realize, all this time I've spent like trying to optimize things for little or no gain has just made my code harder for me to maintain. And you start realizing the value of like, oh, I'm going to write my code so that it's easy for me and others to deal with first, and then if I need to optimize, then just like what was said in the comment here. For me, the shorter version is more readable, more logical perhaps. Oh, interesting. Cool. Yeah, that's good too. Yeah, I mean, if the shorter version works for you, I mean, yeah, and in this case, like if you know about slices and concatenation and ternaries, this is just a nice simple line of code. It's really not that bad. I've definitely I've definitely seen like complicated for loops, like forced into one like monstrously huge nested comprehension, and it fits on a line technically, right? But it's like I've definitely seen comprehensions where I'm like, I do not want to read that. I do not want to try to pick through that. But anyways. Copyright that. I actually that's from a book on C++ that I was reading. I was like, I need to remember that. I should be clear that I don't take credit for that quote. I don't remember the author's name, but yeah. Credit where credit's due, kind of. I'll post maybe I'll post that quote at the end in Slack and a link to that book and that author. Okay, cool. Let's see. Not that I'm not full of gems, just to be clear. I am. I'm absolutely a fount of wisdom, and you should regard me as such, but, you know. All right, let's just jump into another problem. Greatest common divisor. Alphabet symmetry kind of sounds interesting. Let's do this. Train. Maybe I said I would try to go faster, and I think I really didn't. Let's do. There's our thing. Okay, so first thing is our doc string. First thing is just set up. Just kind of lay the foundation. Grab these things. This function's name is called solve. That's great. Okay. Return. We're going to return something. Print, and then we'll say, whoops, res equals exp res. Oh. Let's see if I can do this. It's not gonna work. Okay, cool. Whoops. There you go. So there's our tests. Here's our function stub. Let's try this out. Consider a word abode. I was like abdo. Wow, okay. My eyes are in full overdrive right now. So consider the word abode. We can see that the letter A is in position 1 and B is in position 2. In the alphabet, A and B are also in position 1 and position 2. Notice that D and E in abode occupy the positions that they would occupy in the alphabet, which are positions 4 and 5. Given an array of words, return an array. So an array, if you don't know, if you're familiar with Python, an array, every other language calls what Python calls a list. Most other languages refer to it as an array. So we can read that as a list. So given a list of words, return a list, return a list of the number of letters that occupy their positions in the alphabet for each word. So abode, So basically here's another test. And this might actually be about ABC, XY. Yeah, actually this is our first test right here. Same diff. Oof. I gotta format these. Yes. Yes. Okay. So it's saying, I think what it's saying is that abode has 3 letters in the position of the word that occupy the same position in the alphabet. Did I say 3? I meant to say 4. So A, B, E. Oh, D and E, right. So A, B, D, and E, so 4. ABC has 3. X, Y, Z, D. A, B, C, D, X, Y, Z, D has 1. Okay. Interesting. So I'm following a hunch here. I think if I make a variable called ABCs, and I'm just going to type out the alphabet. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Okay, good. Just want to make sure I got everything in the right order. Okay. So here's my alphabet. I can use the dot index method to get the index. Yeah. All right. So this is going to do, I think we're just going to say word list. We'll take in word list. And then what do I want to do? I'll just call this list, LST, equals a list. And I'm going to say for word in word list. For word in word list. For character in word. If, and I think I'll enumerate, yeah, IDX and character and enumerate word. Whoops. Okay, sorry about that. So we'll say if the IDX of the character equals ABC's dot index of C, we'll have to do wordy county thingy equals 0. I'm in a fun mood. So wordy county thingy plus equals 1. So the reason I'm okay, I'll give this a serious name. What should we call this? IDX index parity counter. Okay. So this is going to count the indices that have or this is going to count the letters that have parity across their indices between the word and the actual alphabet. Okay. So the reason I'm going to do this. This is such a long name. I'm going to call it counter. Okay. So our counter, I'll start my counter at 0 up here, and I'm going to reset it first thing in my for loop right up front, and that's going to reset it at 0 for every word, every time we encounter a new word. Then if the index is equal to, if the index of the character is equal to the index of that character in ABCs, then we're at count equals 1. And after, oh, uh-oh, Mayday. We've got glitches.